Hello, Mr. Betts here. Let's take a look at a few examples where we're going to rewrite integrands using long division and then using that to evaluate antiderivatives. So on this first one here, it looks like a pretty simple expression. However, we don't have a quotient rule for integrals, so we do need to rewrite this. So what we're going to do is we're going to make this division using long division. And it's going to be a pretty quick one. So x goes into 2x 2 times. 2 times x plus 2 is 2x plus 4. And we subtract and we get negative 3. So it's going to be 2 minus 3 over x plus 2. And what that allows us to do is then rewrite this integrand as 2 minus 3 over x plus 2. And that we can evaluate term by term. So the antiderivative of 2 is 2x. The antiderivative here, we could use substitution. I think this is something that you don't have to use substitution if you can kind of see what's going to happen. What's going to end up happening is we're going to use a natural log here. So I'm going to start with a natural log of the absolute value of x plus 2 and just think about what happens when we take the derivative to get this and figure out what we need to do to make it look like it's supposed to. So the derivative of natural log of x plus 2 is 1 over x plus 2 times the derivative of the inside function, which is just 1. So we don't have any problems there, but I need that minus 3. So I'm just going to put that out front. And then we took the antiderivative, so we've got a plus c there. And we're done. Okay, same thing here. We're going to do long division. So we've got 3x cubed minus 5x squared plus 10x minus 3. All of that divided by 3x plus 1. So 3x goes into 3x squared. 3x cubed, x squared times, so just 1x squared. So we get 3x cubed plus x squared, subtract, and negative 5x minus x squared is negative 6x squared plus 10x. 3x goes into negative 6x squared, negative 2x times. So we get negative 6x squared minus 2x, and we subtract. 10x plus 2x is 12x. Bring down the minus 3. 3x goes into 12x 4 times. And we subtract, and we get negative 7. And so that remainder goes over 3x plus 1. So rewriting the expression then, our integrand is going to be x squared minus 2x plus 4 minus 7 over 3x plus 1. We have multiple terms, so we should put that in parentheses. And it's an integral with respect to x. So going term by term here, we're going to get x cubed over 3 minus x squared plus 4x. This is another one where you can use substitution and say u equals 3x plus 1. So we're going to have natural log of the absolute value of 3x plus 1. If we take the derivative of that, we're going to end up multiplying by 3. So to account for that, we need to divide by 3. This part right here, it would not be a terrible thing to take the time and make sure you do it right and say u equals 3x plus 1, du equals 3 dx, dx equals du over 3, and that's where that 3 in the denominator comes from when we make that substitution. This example looks kind of similar to the first one because we have two terms divided by two terms. The trick to this one, though, is we're missing an x squared term and we're missing an x to the 0 term. And when we do long division, we need to make sure we include them. So when we write this out, I'm going to write plus 0x squared plus x plus 0. Just like if we were dividing the number, let's say 1047 divided by 7, we wouldn't leave the 0 out and just say 147 divided by 7. So we need to have all of the place values just like we would if it's a regular number. And then divided by x plus 1. So x goes into x cubed, x squared times. So we get x cubed plus x squared. We subtract, get negative 1x squared plus x. So it's going to be minus x minus 1x squared minus, sorry, that should be a plus x there, minus x. And we subtract, get 2x plus 0. So x goes into 2x 2 times. We get 2x plus 2. And we subtract and get negative 2. So it's going to be minus 2 over x plus 1. So this expression here is going to be x squared minus x plus 2 minus 2 over x plus 1, parentheses around multiple terms, dx. Antiderivative term by term, x cubed over 3 minus x squared over 2 plus 2x minus 2 natural log of the absolute value of x plus 1. I would strongly recommend with expressions like this, take the derivative, especially if we have to use the chain rule, which we don't here because the derivative of the inside is 1. But take the derivative and make sure that we get this. Also, don't forget those absolute values on natural logs.